Right. Welcome to your AP entropy slash enthalpy slash Gibbs free energy kind of AP question walkthrough. So this is going to be super short because most of the AP questions that have to do with entropy and enthalpy's relationship to an equilibrium is multiple choice. So that's kind of nice. We're only going to go over one problem because that's it. And it's a really common question. Often what you see is the AP will repeat formats of questions and just change the variables or the specific species or context that you're looking at, but the type of question is very similar. So you'll probably notice that in your AP classroom quizzes that you see a question like this. So this is showing us question 16 on page 6 is the process of dissolution or dissociation of salt in water. It's represented by the diagram below, which of the following summaries the signs, which of the following options summarizes the signs of the change in enthalpy under standard state conditions and the change of entropy, microstates, under standard state conditions from product minus reactants for each part of the dissolution process. So what you see is in your options, okay, you see that in the process of breaking solvent to solvent interactions, right? Initially, right, when the two substances are separate, they have their own interaction with their own molecules. So what we would see is if I'm breaking bond, or not even bonds, intermolecular forces, right? If I'm breaking intermolecular forces, I know that I'm having to input energy, right? Because I have to put in energy to start kind of ripping them apart. I also know that as I pull things apart on a physical state level, I am increasing my entropy because I'm creating a more disorganized system. Things are being more random. There are more possible configurations, microstates. So immediately, what you can do is you can just cross out option C and option D because they definitely don't have the right first stage description of the enthalpy and entropy. Moving on to the next one, breaking solute and solute interactions. Okay, well, it's the same thing. It's just like looking at a different particle. We're going to see that we're going to take in energy to do that. We have to break apart those intermolecular forces, and we're going to create a more disorderly state for the solute particles. And so A and B are still in the game. So what we look at then is, okay, what about the solute versus solvent interaction? So if I'm forming solute-solvent interactions, theoretically, that means I'm stabilizing. I am lowering my energy. I'm bringing stability to the particles. So we'd actually see a release of energy. And a dissociation is known for actually being, I believe, quite exothermic. Gosh, I hope I'm not wrong. If my memory serves me right, it kind of depends on the particles because, every sample is slightly different. But yeah, so, and then the solute versus solvent interaction, well, your entropy would definitely be decreasing because what you're doing is you're bringing back order. You're now taking a highly disorganized system of just all these particles kind of like that are now on their own. They're like not they're not grounded by any other particles interaction, and they're going from kind of being like a free particle to now being grounded once again in a new intermolecular force with the solute and solvent partnership. So what we see then is A is our answer. And you're like, that was a really long explanation. And you're right. You're very right. You probably should have been able to answer this question and could have in like 30 seconds, which by the way, should be a goal. This is totally a time saving type of question in the AP, at least all the AP practice questions and tests I've seen. Entropy and enthalpy tend to be in relationship to looking at a system in Unit 7 context, a very much time-saving type of question. So that's all I have for you guys. Please start studying for your Unit 6-7 test by going into AP Classroom and taking the 3 quizzes I've released. In addition, finish up your workbook problems. We started several AP problems that we never finished. Or there are just like 3 or 4 AP problems that we haven't even started. So your goal is to finish the workbook pretty completely and then go into AP Classroom and take quizzes maybe once, one round, just to see if what you know under the time frame, 1 minute and 30 seconds per MCQ, and 9 minutes for a short FRQ and 23 minutes for a long FRQ. Okay. And then go back again and really parse it out. All right. Of course, email me with any questions. Best of luck, everyone. Definitely spend a little time this weekend preparing. Bye.